Dear friends, today we are going to discuss about function of normal probability curve in this video. Function of normal probability curve is also known as probability density function. In short, it is called PDF. It is also known as Gaussian function because a German mathematician Carl Friedrich Gauss has contributed in the development of this function. Sometimes it is simply referred as Gaussian. It is a mathematical function. It is used in statistical analysis of data also, especially in research. It gives symmetrical bell-curved graph as shown on the screen at the right side. Probability density function FDP is like this: f of x equals to 1 upon sigma in root 2 pi into e raised to minus 1 by 2 in bracket x minus mu upon sigma whole square, where sigma is standard deviation of data, pi is pi, it has constant value 3.14159, x is any single observation or row score of our data set, e is a mathematical constant, its value is 2.71828, mu is average or mean of all the observations. Friends, we know that z equals to x minus mu upon sigma. We have discussed a lot in some of the previous videos about z. Z is a standardized score. It is also called z score or sigma score. In our function in FDP, in probability density function, x minus mu upon sigma is used at the end. In place of x minus mu upon sigma, if z is written, then we have to change this value in the function, where 1 by 2 in bracket x minus mu upon sigma whole square will become z square upon 2. If this is placed in place of half x minus mu upon sigma whole square, then the function will be like this: f of x equals to 1 upon sigma in root 2 pi into e raised to minus z square upon 2. Friends, normal probability curve and standard deviation has some specific kind of relationship. Standard deviation affects the width and height of the curve. How? If the value of standard deviation is small, the curve is narrow and height is more, as shown in the figure. If the value of standard deviation is small, then the height of the curve will more and its width will be less. It will be narrow. If the value of standard deviation is large, the curve is broad and the height is small, as shown on the figure at the right side. When standard deviation is large, then width will increase, it will be broader, and the height will be small. Friends, like normal probability curve, normal standard distribution is there. It is like normal distribution, but it is called normal standard distribution. What it is? It is a symmetrical distribution. It is also called Z distribution. It is obtained by converting the row scores in Z scores. And to convert row score in Z score, we use this formula: Z score equals to sigma score equals to x minus mu upon sigma. For each and every row score, we will have Z score or sigma score, and the range of Z score is between minus 3 less than equal to Z less than equal to 3. It also gives bell-curved graph. Z distribution or normal standard distribution gives bell-curved graph like normal probability curve. It has 6 parts: first part starts with z equals to minus 3 and last part ends with z equals to 3. In place of z value we can write sigma value. For that we can write in this way, minus 3 sigma in place of z equals to minus 3, minus 2 sigma in place of z equals to minus 2. In the same way, minus 1 sigma, 0 sigma, 1 sigma, 2 sigma and 3 sigma will be written respectively in place of z equals to minus 1, z equals to 0, z equals to 1, z equals to 2 and z equals to 3. And the most important thing in terms of normal standard distribution is it has mean 0 and standard deviation 1. You take any z distribution, any normal standard distribution, then we will get mean 0 and standard deviation 1. Friends, in this video we have discussed about probability density function, that is function of normal probability curve. In next video we will discuss more about some other statistical